Okay, so we are on page 8 of our notes. Scale factors and areas of 2D shapes. This opening paragraph, let's just read through it. It says, last section we studied the concept of similar objects, objects who have the same shape but different sizes. Another way of describing the enlargement or reduction of an object proportionally is by scale factors, and that's what we worked on in 8.3, scale factors. Here we explore the relationship between scale factors and the perimeter of an object, as well as the area of 2D objects. Eventually we will get to volume, which would be a 3D object, but that will be 8.5. So let's fill out this first table, and the math here is nothing new, things that we know how to do. So if we look at a specific rectangle, we're going to call it A. It has a length of 3 and a width of 1. We can figure out the perimeter by this. It's 3 plus 1 plus 3 plus 1, which is 8, or we can plug it into this formula. It's going all the way around. Or we can also calculate the area, which is 3 times 1, and it would be 3 centimeters squared. So that's all this first table is filling out the perimeter of these different rectangles, rectangle A, rectangle B, and rectangle C. So we see that rectangle B is a perimeter of 16. It has an area of 12 centimeters squared. In rectangle C, which is the largest one, we see that its perimeter is 40, and it has an area of 75. Right? So again, reminder, we got these values here from the length and the width of this rectangle. So we are going to use those values to actually explain what's going on in the second table. So first of all, let's just talk about what it says right here. It says we are going to compare rectangle B to A. So let's look at the scale factor. The scale factor we are going to get from comparing lengths here. Remember, scale factor is a ratio. So if we compare B to A, B which is 6, A which is 3, we see that that reduces down to 2. C to A if we're going down. C to A, we're just going 15 to 3. Our scale factor is 5. It's an enlargement because it's getting larger. And then if we go C to B, it's 15 to 6, which reduces to 2.5. In the next column, what we're doing, we're comparing the same rectangles. So let's start with B to A, and what we're comparing is the perimeters. We're not comparing just the length. We're going all the way around. So if we compare 16 to 8, this value to this value, we see that we get 2, which is the same scale factor that we see there. We compare the perimeter of C to A, we see that, hey, we're getting the same value as a scale factor if we compare their perimeters. And we should expect the same thing with the last one. 40 over 16 is the same as 2.5. Okay, so that's one thing that we wanted to take away from this lesson. The second one has to do with area. How does area, what's the ratio when we compare these things? So again, we're starting with rectangle B and rectangle A. If we look at rectangle B, it is 12 centimeters squared. Rectangle A is 3 centimeters squared. We put this and reduce it, and we see that that becomes 4. If we find the square root of 4, we see that that is 2. So there is a relationship between this value. It's not just random. So we could say that the scale factor squared, which we see right here, 2 squared, is equal to the ratio of our areas. And we're going to see this phenomena on the next two, right? Looking at this, if this is 5, we're going to see that the ratio of the areas should be 25. And that's what we see. So if we do the square root is 5. And the last one we see will be 6.25. So this is the important thing that we have to take away from this lesson, that the ratio of the areas is the scale factor squared. And we'll write that in our next little part here. It says, what is the relationship between the scale factor and the ratio of the perimeters? Well, we saw no change, right? The ratio of the perimeters is the same as the scale factor. Or then ask the question, what is the relationship between the scale factor and the ratio of the areas? And we said the ratio of the areas is the scale factor squared. That's what we saw in the very last column. Okay? So let's take that information and see if we can solve this first problem. It says Jasmine is making a kite from a 1 to 20 scale diagram. The area of the scale diagram is 30 centimeters squared. How much fabric will she need for her kite? So we notice we have the scale, which is highlighted in blue. So let's see what we can do with that. First of all, if it's a ratio of 1 to 20, we can turn that into a fraction, or we may want to work with a decimal. That might be easier for us to work with in the question. So here's the idea. If we have this is our formula from before, from last section. Object is equal to the image over the scale, and that's scale factor. But when we're talking about area, it's object area over the image area over top of the scale factor squared. So what will we be squaring? We'll be squaring our 0.5. So here's what we have. If you look at the image area, we were told it was 30. The scale factor we're putting on the bottom is 0.5. So how much fabric will she need for her kite? 12,000 centimeters squared of fabric. And that's the answer. And that's it for page 8 notes. On to page 9.